Welcome back. The next is the basic rules of probability. So here we're going to be looking at theoretical method of equally likely outcomes, which is simply always you start with the total possible outcomes, which is also called as your sample space. So as you can see, probability is simply the denominator is the total number of outcomes, and on the numerator you have number of ways of that event occurring. Again, this makes much more sense when we do it step by step. So let's go ahead and take a look. It was observed over the past year that it rained on 105 of 365 days. What was the probability of any day being rainy last year? Again, we will start with number of ways. That means how many times or how many days did it rain? It rained 105. How many days do you have in a whole year? You have 365. So your probability is simply 365 over 105. Keep in mind you will always simplify your answers. So this is your final answer, but you always have to simplify your answers. Let me go ahead and plug this into ClassCalc. 105 divided by 365. You will change from decimal to fraction, which is 21 over 73. So this is 21 over 73. All right, let's go ahead and take a look at the next problem. Edward wants to purchase a ring for his girlfriend. He has narrowed his choices to 5 ruby rings. I'm going to go ahead and highlight these. 5 ruby rings, 6 sapphire rings, and 2 diamond rings. That's very nice of Edward. If Edward randomly chooses a ring for these options, what is the probability that he chooses a diamond ring? Again, we will go ahead and see what my options are. Number of ways he can choose a diamond ring is 2 because there are only 2 diamond rings. What are the total number of outcomes? He can choose from rubies plus sapphire plus diamond. So that is going to be 5 plus 6, 11. 11 plus 2 is 13. My probability is simply 2 over 13. Okay? All right. A dairy farmer milks his cows every day. He determined the chance that he gets anywhere between 12 and 14 gallons of milk in one day is around 32%. Identify the method of probability that the farmer used to reach this conclusion. They are asking me, is it theoretical or relative? So keep in mind, he's not giving me the estimate. He's giving me the estimate of the next day based on his previous days, right? So that is a relative frequency. All right. A deck of cards contain red cards numbered 1, 2, 3, 4, 5, 6, blue cards numbered 1, 2, 3, 4, 5, and green cards numbered 1, 2, 3, 4. If a single card is picked at random, what is the probability that the card has an odd number? So let's go ahead and see how many cards we have all together. I'm going to count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 cards all together. And what are they asking me? The probability that the card has an odd number. So let me erase these and see how many odd numbers do I have. I have 1, 2, 3, 4, 5, 6, 7, 8. So it's simply probability is 8 over 15. Fair enough? All right. Nick needs one more class to complete his schedule. There are 5 writing classes, 3 history classes, and 4 mathematics classes that can fit his schedule. If Nick chooses a class at random, what is the probability that he can choose a history class? So let's start. How many history classes does he have? 3 history classes. What's the total number of classes? 5 plus 3, 8. So 5 plus 3 plus 4. So what are 5 plus 3, 8. 8 plus 4 is 12. So the probability is simply 3 over 12, which is 1 over 4. Fair enough? Always you have to reduce your final answer. All right, let's take a look at the next one. This is describing more than one event. A deck of cards contains red, 1, 2, 3, 4, 5, blue, 1, 2, 3, green, 1, 2, 3, 4, 5, 6. If a single card is picked at random, what is the probability that the card is blue or has an odd number? Remember, or is to combine. So let me go ahead and write that down. Or is to combine. Okay, so let's start with how many odd numbers we have. So odd numbers, let me start counting. 1, 2, 3, and 4, 5, 6. So I have 6 odd numbers. Do you see that? I'm going to count the blues, but because I'm not going to count them again. So let me count. All right, let me restart this one. I think that was a bit confusing. Let me restart it. First, let me go ahead and count how many blues I have. So 1, 2, 3, 3 blues plus I'm going to see how many odds I have. 1, 2, 3. I don't need to count the odds in the blue because I counted them already. I'm going to go to the green. 4, 5, 6. So 3 plus 6, 8. So totally I have 8 cards that are blue and also odd, right? Now the total number of outcomes, how many cards do I have in all together? So let me go ahead and count those. I have 5 red cards. 5 plus 3 is 8. 8 plus 6 is 14. So I have 14. So your probability is simply 8 over 14. And again, you're going to simplify this to 4 over 7 as your final answer. Fair enough? All right. Again, remember what I did? I did not count the blues again because I counted them once already. A psychology test has a personality questions numbered 1 to 3, intelligence questions numbered 1 to 3, 4, and attitude questions numbered 1, 2. If a single question is picked at random, what is the probability that the question is an intelligence question or an odd number? So let's go ahead and see how many intelligence questions do we have. Let's see. Intelligence questions 1, 2, 3, 4. So 4 intelligence plus let's check at the odd numbers. 1, 2, 3. So intelligence or odd together is 7. Now let's go ahead and see how many cards do we have in total. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my probability is simply 7 over 9. Fair enough? Then that is going to be your final answer because you cannot simplify that further. All right. A restaurant is offering chicken specials. What's up with these chicken specials? Numbers 1 to 3, beef specials numbered 1, 2, 3, 4, vegetarian specials numbered 1, 2. If a single special is picked at random, what is the probability that it's not vegetarian? That means it could be a chicken or a beef. So let's go ahead and see how many chicken or beef do I have. 1, 2, 3. 4, 5, 6, 7. So 7 chicken or beef that are not vegetarian. How many total outcomes? Let's go ahead and count them again. I have 1, 2, 3. 3 plus 4, 7. 7 plus 2, 9. So my probability is simply 7 over 9. Okay? All right. Of the last 3 chapter tests given in a computer programming class, 11 students pass all 3 tests. 9 students pass 2 tests and 2 students pass 1 test. If a single student is picked at random, what is the probability that the student pass all 3 tests or 1 test? So let's go ahead and see how many of them pass all 3. How many of them pass all 3? 11 passed all 3. So 11 Or is plus. How many of them pass one test? Two students passed one test. So that's 13. But how many students do I have altogether? Let me erase these. I have 11 plus 9 plus 2. That is 11, yeah, 11, 9, and 2. So I have 22 students together. So my probability is going to be 13 over 22. Fair enough? All right, let's take a look at the last problem. A voter in an upcoming election has many different types of issues on the ballot. Of the issues on the ballot, 7 are school related, 10 are ordinance related, and 2 are library related. Library related. Ugh. If a single issue is picked at random, what is the probability that the issue is school or library related? Why do they do that? So let's go ahead and see how many school. Remember, OR stands for addition, you're combining. So let's go ahead and see how many are school issues. School issues, I have 7 are school, 7. OR is addition. How many of them are library? 2. 7 plus 2. So totally I have 9 that are school or library. But how many issues do I have in all together? 7 plus 2 plus 10, 19. So my probability is simply 9 over 19. Fair enough? Again, if you have any questions, please make sure you reach out to me via email or Teams. And please do this step by step. If you have any questions, you know how to reach me. All right, good luck.